Hello everyone, how are you all? So today we are going to discuss an algorithm based on real-time task scheduling. So the problem statement, the algorithm to efficiently schedule tasks on a multiple processes or machines in a distributed computing environment. The algorithm should optimize resource utilization, minimize task completion time, and handle dynamic changes in the task priorities or resource availability. So which algorithm are we going to use? We are using SJF, shortest job first algorithm, to allocate tasks to processes based on their execution time, priority, or other criteria. Implement load balancing techniques to distribute tasks evenly among processes and adaptively adjust task assignments based on real-time resource usage and availability. So let us look at the efficiency of SJF. SJF minimizes average waiting time and turnaround time, making it efficient for minimizing overall completion time when all task lengths are known in advance. So in this SJF algorithm, we are given the task lengths in advance in order to find the average waiting time and turnaround time and making it efficient and minimizing overall completion time. So the use case ideal for batch processing systems or environments where task lengths are predictable. So let us look at the time complexity. The time complexity of the shortest job first scheduling algorithm depends on the implementation and the data structures used. So it may be a queue or a list. So there are two types of SJF. One is non-preemptive, the other is preemptive. So non-preemptive SJF. In a non-preemptive SJF algorithm, once a job starts executing, it continues until it finishes. So what does it mean? It means, let us take an example. We have a process called P0 and it's executing. So there won't be any process interrupts the P0 process and starts to execute. So in this non-preemptive SJF, we are only given the burst time. We are not given the arrival time for any of the process. So there won't be any interruption in between. So therefore, the time complexity mainly depends on the sorting the jobs based on their burst times. Sorting the jobs by burst time can be done using efficient sorting algorithms such as quick sort or it may be merge sort. So the time complexity of a sorting n jobs with burst times is typically O n log n. So let us discuss an example based on non-preemptive SJF. So we've given four processes P1, P2, P3 and P4 and the respective burst times 6, 8, 7 and 3. So we're going to sort the burst time. So if we sort it, we'll get 3, 6, 7, 8. So the first process which is going to execute is P4. So P4 is going to execute for 3 milliseconds. So 0, 1, 2 and 3. So after that we have P1 process. So the P1 process started executing for 6 milliseconds. See, you can notice that while P4 process executing, P1 process does not interrupt the P4 process. So this is what we call as non-preemptive. Okay. So P4 is executed, P1 is also executed. Then after that, after 6 we have 7. So P3 will get executed for 7 milliseconds. And finally we have P2 here. So P2 will be executed for the rest of the time, 8 milliseconds. So we'll take a look at the waiting time for each process. The first executed P3 process. So it is a first executing process. So there is no need to wait for the process. So the waiting time for the P4 is 0. Secondly, we have a P1 process. It has to wait for 3 millisecond because we have the burst time 3 for P4 process. So it has to wait for 3 milliseconds and then P1 will be executed. So the waiting time for P1 is 3 and then P3. P3 has to wait for P4 as well as P1. So 6 plus 3 goes 9. So it needs to wait for 9 milliseconds. After that, P3 executed. And finally, P2 gets executed after 16 milliseconds. 3 plus, uh, 3 plus 6 plus 7. So 16 milliseconds. It has to wait. So now let us look at the preemptive SJF. In a preemptive SJF algorithm, the scheduler may interrupt the execution of a running job if a new job with shorter burst time arrives. So, if there is a new job with shorter burst time, the priority will be given to that job and it will execute first, and then it will continue the rest of the process to execute. So, in this case, we'll be given the arrival time as well as the burst time. So, typically, a priority queue is used to store the task sorted by the burst times. And then inserting a new task into the priority queue takes O login time, as well as extracting the shortest job from the priority queue also takes O login time. So the time complexity for preemptive SJS will be O n log n, considering all the tasks. So let us look at a example for a preemptive algorithm. So this is the Gantt chart, and then we've given the process arrival time and burst time. So P1 process arrives at 0 millisecond, P2 at 1, P3 at 2, finally P4 at 3. So the P1 process and arrival time is 0. So it's the first process which is gonna execute. So it will be in the Gantt chart and it's going to execute for 1 millisecond. Why 1 millisecond? Because look at the arrival time of P2. At 1 millisecond, we have two processes in the priority queue. So which is P1 and P2. So P1 has executed 1 millisecond already. So the remaining burst time will be 5 for P1, and the P2 has just arrived and it has 4 millisecond. So as I said already, we need to sort the burst time and accordingly we need to execute the processes. So 5 and 4. So P2 has the less burst time, so it will be execute for another 1 millisecond. Why? Because process P3 is arriving at 2 milliseconds, so till that it will be executing for 1 millisecond. So now in the priority queue we have three processes. P4 has not arrived yet, only 2 millisecond has completed. So we have in the priority queue P1, P2 and P3. So the remaining time for this will be 5 as I told already, and then 1 millisecond has executed for P2, so this will be 3. So 5, 3 and 2. So which has the less burst time now? 5, 3 and 2. We have P3 process which has a less burst time. So P3 will be executing for 1 millisecond. So after 3 millisecond, we have P4 process in the priority queue. Now we need to check. So at this time, P1 has 5 millisecond, P2 has 3 millisecond remaining, and P3 has 1 millisecond. So we all know 2 to 3 has completed. So we have 1 millisecond remaining for P3 and P4 has 3 milliseconds. So now we need to sort this remaining burst times. So we'll get P3. We'll get only P3 because which has lowest burst time. Since P4 does not have a shortest burst time, P3 continues to execute. So P3 will be executed. P3's burst time will be 2. Also, the P3 will be completely executed. Now, at time T4, P3 is finished now. Now, remaining tasks are P1, P2, and P4. P3 is completed. So now we need to check uh, the burst times of these three processes. We have 5, 3, and 3. So we just don't consider 5. P2 and P4 have same burst times. So in this case, which one will you choose? In this case, we need to follow the FCFS, the first scheduling algorithm rule. So we need to look at the arrival time now. As P2 and P4 have same time, so the task which came first will be executed first. So FCFS follows here. So the process P2 will be executed first. Okay, we have three. Uh, both process have burst times 3, but P2 has arrived before than the P4. So the P2 will be executed for how much second? For 3 milliseconds for 5, 6, and 7. and then we have a P4 process. So now P2 and P3 got over. So we have remaining process P1 and P4. So among these two, we have P4 as the shortest burst time. So P4 will be executed for 3 milliseconds, and finally we have P1 here. P1 will be executed for the rest of the time. So that's what given here. So yeah, we look at the waiting time. So for this problem, the waiting time can be calculated by completion time minus burst time minus arrival time. So for P1 process, uh, the completion time will be 15. So you can see for P1 process, the completion time will be 15, and then the waiting time will be 6. The waiting time will be 6, and then sorry, the burst time will be 6. The burst time will be 6, and the waiting time will be 0. So it is the first process which is executed, so it has no reason to wait. So if we calculate, we'll get 9 milliseconds. Similarly, we can calculate P2, P3, and P4. So the average waiting time will be 9 plus 2 plus 0 plus 4 divided by 4 will be the 3.75. So thank you guys. I'll see you in another video.